Hello and welcome back to another video. Today we're going to be looking at the Calc Bc free response question from 2019, the first one. So in this one it says fish enter a lake at a rate modeled by a function e given by e of t equals 20 plus 15 sine pi t over 6. Fish leave the lake at a rate modeled by the function L given by L of t equals 4 plus 2 to the 0.1 t squared. Both E of t and L of t are measured in fish per hour, and E and t is measured in hours since midnight, t equals 0. First, it asks us how many fish enter the lake over the 5-hour period from t equals 0 to 5. Give your answer to the nearest whole number. Okay, so when we're looking for a value like this, basically what we have to do is we have to integrate a rate, right? So let me just write that down. Integrate a rate to get a value. And what rate are we integrating? Well, it asks us how many fish enter the lake over the 5-hour period from t equals 0 to t equals 5. So basically, we're going to be integrating e of t, because that's how many fish enter the lake. And we're integrating from 0 to 5, and that's dt. Okay, so basically what we're going to do is we're just going to plug that into the calculator, and we'll see how that goes. All right, let me just pause now. All right, so I've gotten the calculator working. So we're integrating, let's see. We are integrating e of t from 0 to 5. So let's put that in. And that's 0 to 5 of e of t. And now what is e of t? E of t appears to be 20 plus 15 times sine of pi t over 6 dt. And that gives us this value, which is 153.458. So let me just write that down. 153.458. Right. So next we've got part B, which tells us, well, it asks us, well, yeah, okay, first let's go back here. Nearest whole number will be 153. All right. What is the average number of fish that leave the lake per hour? Average number of fish, very important to write that down, over the 5-hour period from t equals 0 to 5. All right, so average value. Basically, we're going to be multiplying by 1 over b minus a with this integral a to b of, well, f of x dx. And it's asking about the fish that leave the lake. So f of x will be our L of t, right? So first we're integrating from 0 to 5, and that's going to be 1 over 5 minus 0 is 5. And this is L of t dt. And now we're going to do the same thing as before. Let's get our calculator out. And let's see. 1 over 5, just 0.2 times the integral from 0 to 5 of this L of t, which is 4 plus 2 to the 0.1 t squared dt. And that gives us 6.059, whatever. And it says to the nearest whole number. Yeah, it says the nearest whole number. So we're just going to be saying that it's equal to 6. Well, 0.0594 equals 6. Well, not equals, but arrow to 6. You get what I mean. All right, next, part C. It asks us, at what time t for 0 less than or equal to t less than or equal to 8 is the greatest number of fish in the lake? Justify your answer. You know what? I'll justify it out loud, so I don't really need to write a justification down. So we're looking for the greatest amount of fish in between times 0 and 8. Well, how do we have the amount of fish? The amount of fish is going to be equal to the amount that leave, right? The amount that enter minus the amount that leave. Now, we don't really have the amount that enter and the amount that leave per se, but we do have the equations for like how many fish enter per hour and how many fish leave per hour. So as we said before, we're going to integrate a rate to get a value. And for that reason, we're just going to say the amount of fish is equal to the integral from 0 to t of e of t minus L of t dt. And then we're just going to see when is the greatest number of fish in the lake. So we're going to do this, we're going to see what the max of this is. Now, if we're doing the max of something, if we're going to try and maximize that, then we're going to see when the rate, when dy dx is equal to 0. And it's going from usually positive to negative, right? So if we draw our coordinate axes out here, it might look something a little bit like this, where we're going from positive to negative here. Here, the derivative is positive, right? And here, it's obviously less than 0. But here, it's equal to 0. And we know if it's going from positive to negative, then it must be a max. Now, I could take the derivative of the integral of e of t minus L of t dt, but this seems kind of silly. And in reality, we can just kind of cancel these operations out and say we're just going to set e of t minus L of t. We're going to say that's equal to 0. And yeah, so we're looking for the time in between 0 and 8 when that's equal to 0. That value right here. So t equals what? Now, lucky me, I have a TI Inspire CX CAS. Here we go. Time to turn it on and get to work. So let's go to the solve function. And we're looking for a time when e of t minus L of t is equal to 0. So let's go back up, or actually, we can kind of see it up here, these two different functions. Saying 20 plus 15 times sine of pi t, yeah, that should be fine, over 6 minus this 4 plus 2 to the 0.1 t squared is equal to 0. And we're looking for t, and it also said that We were looking for in between 0 and 8. So we're just going to see that right there. We're basically just going to put that in here. So this is going to be a such that 0 is less than or equal to t is less than or equal to 8. And now why are we saying less than or equal to instead of just less than? Because the endpoints are also critical points. So you want to kind of include those. And here, lo and behold, the only t value for which we get t is equal to 0 happens to be t equals 6 point, what did it say? 6.20356, right? All right, well, that's our t value, and that's that. Now for part D, they're asking us, is the rate of change in the number of fish in the lake increasing or decreasing? Increasing or, whoopsie daisy. Is it increasing or decreasing at t equals 5? Well, is the rate increasing or decreasing? That sounds a lot like we're checking whether the derivative is positive or negative, but in reality, what we're checking is the derivative of the derivative positive or negative, right? If something is increasing, it means that the derivative is, or well, I shouldn't say t, so I shouldn't say x, I should say t. The derivative is greater than 0, and if it's decreasing, then the derivative is less than 0. So we're checking whether the, what does it say up here? It says is a rate of change in the number of fish in the lake. So the rate of change in the number of fish in that lake is E of t minus L of t. And now we're asked whether or not this is increasing or decreasing. So we're going to have to take the derivative of this at time t equals 5 and see if it's greater than 0 or, if it's less than 0. So, you know what? Let's do that. We're just going to go up here, delete this, go over here, and delete that. Then we're going to say, wait a sec. We want the derivative of that, right? So we're just going to hit enter for that. And that's just, because I want to keep that value for us. Then we're going to ask our calculator to take the derivative of that with respect to t. It's of this thing. And we're saying t such that, right? T equals 5. And now that happens to be negative 10 point whatever. So equals negative 10.7225, whatever it was, right? Which negative 10 point whatever is definitely less than 0. Therefore, the rate is decreasing. But wait a second, aren't we forgetting something? Was the rate originally increasing? Because think about it. If the rate is negative, if the rate is less than 0 and it's getting closer to negative infinity, if it's getting lower, then it's getting farther away from 0, which means that technically the magnitude of the rate is actually increasing, right? Now, we don't want that if we're still going to say it's decreasing. So we have to first check, is the rate negative? Because if it's negative, then we can say that actually the rate is increasing. So let's just check that first. Let's go back here to our trusty calculator, plug that in, such that t equals 5, and lo and behold, it's 17.8431. The rate at t equals 5 equals 17.8431, which is greater than 0. Therefore, the rate is decreasing. All right, well, those are the answers that I got on the AP when I took it on Tuesday. I guess 2 weeks ago now it is. So hopefully those are correct. But yep. Anyway, thank you for watching, and I will see you next time.